Good evening, everyone. We are in the week 4 problem solving session of the NPTEL course, Network Analysis. And week 4 is about mesh and nodal analysis with time varying source. I am Teja Golla, a fourth year research scholar working under Dr. Santanu Kapat at Embedded Power Management Lab, IIT Kharagpur. So before we get started, let me just quickly summarize what we have discussed in the previous week, because whatever we will be discussing today, it is continuation to what we have already discussed in the last week. So is my screen visible?
Yes, sir.
Okay. So let us just quickly go through what we have discussed in the last week. So in the week 3 network analysis, we have discussed about solution to linear differential equation. So we have first discussed about why solution is needed, because any RLC circuit can be written as a linear differential equation. Then we have seen that uh, we can write a time domain expression which we have to solve. So then what we did is we have started with a first order differential equation, and then we have derived normally, and then we have realized that it has one natural response, also it has one forced response. Then we have seen that natural response we can directly write by getting the solution of this equation, and natural forced response is just an infinite series of the derivatives of that input, the one that is there on the RHS side. Then we have summarized for first order differential equation. This is the oral solution, generalized solution. Now using this, we can get the solution. So this green color one is the natural response, which we are getting from this A, and the orange color one is what we are getting from the forced response because of this x of t. And there is one exception: when x of t is equal to the e to the power minus at, then you cannot directly apply the solution. In that case, you have to derive it properly, and then once you solve it, you will get this type of expression. So this you can apply as long as x of t is not e to the power minus at, but only in that particular case when x of t is e to the power minus at, then you have to be very careful, and then you have to take this expression, because if you differentiate e to the power minus at, you will get infinite series of e to the power minus at. So this is not properly applicable.
So,
So yes, yes.
um, in the previous semester, I had probability and complex functions. So
Okay.
in that, by for using differential equations,
Mhm.
there were many formulas.
Okay.
Using that, it can be solved. That
Okay, actually, good question. First of all, good evening, Jnanendra Singh. So it is not that we cannot differentiate it. It is that whatever solution that we have gotten, it is not applicable, because once you substitute e to the power minus 80, you will get something like, because differentiation of e to the power minus 80 is e to the power minus 80. So overall, it can be written as some constant k into e to the power minus 80. But once you actually differentiate it and solve it, you will get a plus bt into e to the power minus 80. So this bt term you will not get you from this expression. So that's why this what we are calling exception. So in every concept, first we'll generalize the solution and then see if there are any exceptions. For that case, we will not apply the direct solution. But it is not that we are unable to find the differentiation. Yes, we can find it, but it is not applicable. Get it? Did you get it?
yes,
Uh, Okay. Then we have written the steps so that we can solve any problem. So first we have to write the generalized solution, and then the forced response constant you will get by substituting the y of t in the LDE. So which is this orange color. First we will get this k0, k1, k2 by substituting this y of t in the LDE, which is this linear differential equation. Then e to the power minus 80, this coefficient a, you will get from the initial condition. Then we have solved a few problems on how to solve this. Two problems we have solved before we go into differential second order differential equation. So for getting the natural response, you have to find the roots of the LHS side. So once you get m1 equal to m2 or m1 not equal to m2, you will get different type of natural response. Forced response remains the same irrespective of the order of the differential equation. So only If this m1 is not equal to m2, then you have two terms. If m1 equal to m2, then you have at plus b. If they are complex conjugates, then you have to realize that a1 and a2 are also complex conjugates, and this complex conjugate will leads to cosine and sine terms. Yeah, someone was asking something.
For
Hi
the
sir, good
x
evening. Yeah.
axis,
Uh-huh.
for
Your
that x
voice is
axis
breaking.
is equal to for e power minus at, sir.
Uh-huh.
Can final answer would be e power minus at by 1 plus n. So
No,
1 e
this
or only e power minus 18, sir.
e to the power minus 80, if you differentiate, it will be minus a into e to the power minus 80. But the solution you will be getting is a plus bt into e to the power minus 80. Like once you substitute it and apply integration and solve, then you will get a plus bt into e to the power minus 80. Is that your question or did I miss it? Can you repeat? Hello.
So we had the same differential equations, same, but instead of uh, forced responses,
Uh-huh.
the term is different, but the same concepts. But by different method, by using formulas, we are getting that answer. So shall I use that like that, or should I follow this?
Which method? Like I'm not following. Can you please repeat?
In previous semester, we studied probability and complex functions.
Okay.
In that ordinary differential equation chapter is this. So in that we are using the same concepts, but in different method. By using formulas, we are
Okay, they are using formulas. Like here, we'll not rely on any formula. We'll use this generalized expression. Maybe they have a dedicated equation for which they are having a direct formula and they're applying it. But issue with remembering the formulas is they are only applicable to certain equations. So if the equation is changed, you can no more apply the formula. So you should always follow a generalized method, and you have to remember that because that can be applicable to any equation. So if you see, like even if it's a second order or if it's a nth order, first what are the steps that we are following is the same. First we have to get the generalized equation. So for any nth order, first we'll get the natural response and forced response, which is same for any nth order. But for natural response, depending upon the order, say if it is second order, you will get two terms depending upon the roots. If it is nth order, you will get either n terms. If some of them are equal, you will get a different case. But first you have to write the solution. So once I write the solution, then you have to find the forced response constants by substituting y of t in LDE, and then natural response constant using the initial condition. So this method is very generalized. So even if it is second order, third order, you can still apply. But issue with the formula is it is applicable to one particular equation that they have taught in that course, which may not exactly overlap with the equations that you will get in this course. So maybe it will be applicable, maybe it will not be applicable. Say if it is applicable, it will save your time, but say if it is not applicable, then again you have to follow this method. So in that case, you are remembering two methods. Now, if you just stick to this method, you can apply to any equation. Is that clear? Hello. Who was asking? Shamita, is that clear?
so how to find forced responses.
So forced constants you have to find by substituting this solution in the original differential equation. So let us just go to this problem. So here I got this k naught t plus k1. So once we substitute this in this expression, then we have LHS and RHS. So I have compared t coefficients and then I have compared constants and then I have equated
How the
LHS.
k0,
Sorry,
how k0 t plus k1
sorry.
why
Can
you
you please?
start up to k1, sir?
Y is
K Why you stopped to K1?
Because this is time, right? So what is the first derivative of t? It is constant, right? 1, right? And what is the second derivative of t? It is 0, right? So it will vanish after second derivative.
Okay, sir.
Yeah. So if it is, say, in this question, it is constant. So we'll have only k naught x. K1 x dot will become 0. So I have written 10 into k naught because the term will vanish depending upon the, or say if it is t square, then third derivative will become 0. So depending upon what value we have here, the number of terms will vary.
Okay.
Okay. You did not join in the last week, I suppose, right? Or maybe you have joined the other
But
session.
I got answers from that what I have studied in previous semesters, so
Okay,
that
okay,
I
okay.
didn't leave.
Okay, okay. But I highly recommend you to follow whatever methods that are introduced in this course because that will be helping you. Because if you combine two different concepts that are covered in two different courses, it might not be helpful. Like once you get the overall picture, then you are free to choose whichever method is comfortable to you. But as far as this course is concerned, because if you miss out whatever is taught in this course, maybe this will be helpful in some other week. Maybe in that week, whatever you have learned in that other course might not be helpful. So you will be struggle. So let us just stick to what this course has uh, is taught like in this course. But once the course is over, then you are free to choose like, but you should learn both the methods. It's not that you will not learn. This is the learning stage. You should learn multiple methods and then you decide which is easier and then you follow that.
Okay.
Okay. Okay, so now let us start with week 4. So now that we have just summarized what we have discussed in the last week, so let me just quickly go through what we'll be covering in this week. So in this week, we'll start with the sinusoidal terms. So we'll deal with the mesh and nodal analysis with time varying source. So time varying source means we'll be considering what we'll be considering. We'll be considering a sinusoidal response. Okay. So mesh and nodal analysis with time varying source. So I have planned to derive using the differential equation, but let us see whether time permits or not. Then I'll skip this part and go to the actual theory part. Or maybe I'll just skip this derivation and we'll directly see. Let us just check how much time we have. So what Sir has done is Sir has considered one RLC circuit with a source. Okay, so this is resistor L, this is L, R, L, and they are closing it t equals to 0, and then they are having this source as Vm sine omega t. So now let us write the KCL, KVL. So what we'll be getting, we'll get VR plus VL equals to Vm sine omega t, right? So what is VR? VR is IL into R plus VL is L DIL by dt, which is equals to Vm sine omega t. So now let us rewrite this equation. So we will be getting dIL by dt is equals to, sorry, plus R by L into IL is equals to Vm by L sine omega t. So is this clear until this point, everyone? Yes. Okay. So
Yes.
now sine omega t you can write as e to the power j omega t minus e to the power minus j omega t by 2j. So which is what we'll be doing. So I can write it as dIL by dt plus R by L into IL is equals to Vm by L into e to the power j omega t minus e to the power minus j omega t by 2j. I hope everyone is aware of this. Anyone has any doubt or is it clear? I hope everyone is aware of this.
How that came?
So basically we have this. So e to the power j omega t is nothing but cos omega t plus j sin omega t. So now if you have e to the power minus j omega t, then this formula is cos omega t minus j sin omega t. So now if you substitute it, you will get sin omega t is nothing but e to the power j omega t minus e to the power minus j omega t by 2j. So you can just substitute it back and check whether it is coming or not. Okay, so now that we have a first order differential equation, we all first what we have to do is we have to write the output equation. So the output equation will be IL of t is natural response. What will be the natural response term? Anyone? What will be the natural response term?
A to the power of minus RL R by L into T.
Yes, very good. So it will be a into e to the power minus RT by L. And in the last week, I have not covered what happens if there is an exponential term. So if there is any exponential term other than e to the power minus RT by L, then we can write it as some k1 into e to the power j omega t plus k2 into e to the power minus j omega t, because the input response is 2 exponential, so we'll also be getting 2 exponential. So now if I consider this is the natural response and this is the forced response. So now what happened? We got the generalized solution. So from this, what we have to find is we have to find a, k1 and k2. Okay, I forgot to give the initial condition. So here initial condition is IL of 0 equals to 0. So now what happens? How will we find K1 and K2? Anyone? With respect to what we have discussed in the last week? How to find K1, K2? Anyone? So someone has mentioned in the chat, put forced response in the differential equation. Very good. So once we substitute this forced response, I'll write down what we'll be getting. So we will be getting dIL by dt. So I'm directly writing the expression. So if you face any difficulty, please stop me. So it will be K1 into j omega into e to the power j omega t plus k2 into minus j omega into e to the power minus j omega t plus k1 r by l e to the power j omega t plus k2 r by l e to the power minus j omega t equal to Vm by L into e to the power j omega t minus e to the power minus j omega t by 2j. So is this step clear? I have just directly written the expression. You just substitute this and I request everyone to write the expression along with me. If you just see me writing the expression, you will not actually appreciate what is going on and you will also not get what is going on. So I request everyone to take a pen and paper, preferably book and paper. You keep a dedicated book for this lectures and solve along with me. Maybe you can solve ahead and if you make any mistakes, then you can correct. So now what you have to do is you have to compare the coefficients of e to the power j omega t. So maybe so e to the power j omega t coefficient, e to the power j omega t coefficient, and then e to the power j omega t coefficient. And then e to the power minus j omega t, e to the power minus j omega t, and then e to the power minus j omega t. So around this part. So now let us write the expression. So we'll get two equations. First equation is k1, if we take common, k1 into r by l plus j omega is equals to Vm by 2jl, and the other expression is k2 into r by l minus j omega is equals to minus Vm by 2jl. So is this clear until this point? I have just compared both of them and then compared the values, k1 value, k2 value.
How it came.
So I have compared e to the power j omega t. So segregate e to the power j omega t terms on the LHS and compare the coefficient in the RHS. Similarly, segregate e to the power minus j omega t term on the LHS and segregate it in the RHS and then combine them. So you combine e to the power j omega t terms. Don't
Yes,
just
sir.
calculate in mind, you write. So that's always a good practice. So once you write, you will get it. So everyone got this, right? Now everyone, I hope everyone is clear. And am I going too fast or is the pace okay?
Okay, sir.
Okay. And then, okay. So I'll just skip the calculation part because I assume you will be able to do. So if you calculate K1 from here, I'll skip this part because this is just a small thing that you can calculate because it saves us time. So I'll directly calculate K1. If you take it on the RHS side and simplify, you will get something like this. Vm by 2j into r minus j omega l by r square plus omega square L square. So this is what we'll get K1, and K2 you will get minus Vm by 2j into R plus j omega L by R square plus omega square L square. So this is what you will be getting if you calculate it. But let us assume that we got these expressions. So now I am finding the forced response. What is forced response? K1 into e to the power j omega t plus K2 into e to the power minus j omega t, right? So I am calculating IL forced of t, which I know as k1 into e to the power j omega t plus k2 into e to the power minus j omega t. So now what I am going to do is this e to the power j omega t term, right? So what I will do is I will segregate the constant term and I'll segregate the imaginary term so that I can write in this form. So e to the power j omega t is what? Cos omega t plus j sin omega t, right? But what is cos omega t? Cos omega t is e to the power j omega t plus e to the power minus j omega t by 2, and sin omega t is e to the power j omega t minus e to the power minus j omega t by 2j. So my basic idea is to convert everything into sine and cosine. So let us see how it will be. So once you multiply k1 into e to the power j omega t, so let us segregate r by r square plus omega square L square. Okay. So first of all, take this common. Vm by 2j you take common, and then you will write r by r square plus omega square L square. You take this also common. Then what you will be getting? You will get e to the power j omega t minus e to the power minus j omega t, right? Agree? The first term r by r square plus omega square L square. So I'm just skipping some terms, but you try to calculate it by yourself. Then you will appreciate it. Getting it? Okay, maybe let me write the full expression, then you'll get it. So then the other term will be minus Vm by 2j into j omega L by r square plus omega square L square into e to the power j omega t plus e to the power minus j omega t. Clear? I have just segregated two different terms and then combined the e to the power j omega t and e to the power minus j omega t. Any doubts or is it clear? Clear. Okay. So now from this formula, you can get e to the power j omega t plus e to the power minus j omega t and e to the power j omega t plus e to the power minus j omega t. So, sorry, any queries until this point? Anyone?
The
Yes.
how that e power in
So I have substituted this k1 here and then substituted this k2 here. Then if you see r by r square plus omega square L square here, r by r square plus omega square L square here. So I have segregated those two terms. So I'll get e to the power j omega t from here, e to the power minus j omega t from here. But because there is a minus sign here, the second term will have minus. And in the second term, we have minus j omega L by r square plus omega square. Here also minus into j omega L by r square plus omega square. So if I segregate this, I'll have e to the power j omega t plus e to the power minus j omega t. Get it?
no.
Okay, one thing. Are you writing with pen and paper?
Yes, sir.
Okay, can you just write this expression in this K1 and write this expression in this K2, and then the first term, the constant term, r by r square plus omega square L square, in these two terms, you segregate it. So Vm by 2j will be common and r by r square plus omega square L square will be common. Then you will get this term. And then the second term, you take common j omega L by r square plus omega square L square in the first term as well as second term. Then you will get this expression. Can you do it? Mm. Shamita, are you doing?
We should segregate and write, sir.
Yes, yes, yes. Take the term common and then write. Just let me know once have done. And others, please let me know if you have uh, any queries until this point. Are you able to do? Others? Others, are you able to do?
Segregated, sir.
Okay, you are getting that expression, right? Hello? Hello? Please respond, Shamita, so
Yes,
that we'll know whether you got it or not. You are
I
getting that?
got
Okay, okay. So
it.
let us proceed further. So e to the power j omega t, e to the power minus j omega t, both the terms you know, right? So now what I'll be doing is I'll get this this term e to the power j omega t and e to the power minus j omega t. Uh, okay, so this will be what? This will be 2j sin omega t, and this will be 2 cos omega t. Are you able to see me? Okay. So now once we do this, what we'll be getting is 2j, 2j will get cancelled. Here 2 will get cancelled, and j will get cancelled. So I'll just quickly write the expression that we'll be getting. So we'll get Vm into R by, so again I'll skip one term. So I'll write something like this. So I'll write Vm by square root of R square plus omega square L square into R by square root of R square plus omega square L square into sin omega t minus Vm by square root of R square plus omega square L square into omega L by square root of R square plus omega square L square into cos omega t. So I have just multiplied the denominator, broke down the denominator into two parts. Why did I do that? Because now I can consider this as cos theta, and I can consider this as sin theta. So now if I take this Vm by square root of R square plus omega square L square common, then I'll get sin omega t minus theta, because sin omega t minus theta is sin omega t cos theta minus cos omega t sin theta, where where tan theta is equals to omega L by R. Okay, getting it? I have just skipped a few terms so that we can directly get to the answer. Is
How
it
the
clear?
cost
We, we,
change?
we, which part? This pink color one or the blue color one?
Root R square plus root
So
R
blue
square.
color. Okay.
Pin, pin.
So what I have done is I have used this formula, sin omega t minus theta is equals to sin omega t cos theta minus cos omega t sin theta. So I have used this formula, and then where sin theta is this, cos theta is that, tan theta equal to sin theta by cos theta. So tan theta is omega L by R. Clear?
How cost it that orange color came?
I have assumed it. I have assumed it to be cos theta, and I have assumed it to be sin theta, because if this is cos theta, that will be sin theta, right? Sin square theta plus cos square theta equal to 1. I have assumed that this to be cos theta, and then that will become sin theta, because if you do sin square theta plus cos square theta, it will be 1. Clear or not clear?
We have a
Your
so
voice is breaking, first of all.
omega
Your voice is totally breaking.
L
I'm not
square
able
as
to.
cost.
Your voice is completely breaking.
We are assumed all.
I still cannot hear you.
We
Your
have assumed R square plus omega square L square as cost theta, sir.
No, no, no. This entire term. Okay, my bad. So this entire term cos theta. This entire term is psi theta. Get it? Is that fine?
We can assume like that in any problem, sir.
Yes, yes, you can assume. Like until they have not mentioned, you are free to assume because here I'm not committing any mistake. Sin theta is less than 1, first of all. Cos theta is less than 1, and sin square theta plus cos square theta is 1. So I am not violating any trigonometry or any rule. So you are free to assume. And I am assuming this so that my answer will become simplified. Nothing much. Okay, first of all, one announcement. The time is less than 1 minute. So this meeting will end. So once this meeting ends, kindly join back so that we can continue. So till now we are simplifying the forced response only. So let me write the IL of t expression. So till now whatever we have got is IL of t equal to a into e to the power minus RT by L plus Vm by square root of R square plus omega square L square sine omega t minus. So
How
okay.
to remember all these methods and also.
Like, see, I'll tell you my experience. So when I was a student, so I used to think like how to like remember all these things for exam. But see, one thing the philosophy of life or any course is like they will teach you many things which you might or might not apply in your life. But when you are learning, you should try to remember things because anyway with age you will try to forget things, but as a student you have to like train yourself, you have to practice to remember all these things. This concept whatever I am teaching, so this is just a derivation of how to get the solution of this. So this will not be a part of uh, today's assignment. But why I am teaching? Because in order to teach what will be used in this week, you should also know this process. Right. So whenever you are learning, you should learn things. But once you have learned things, how many of those things you will be remembering or how many of those things will be needed for assignment, that's a different thing. So the aim of today's discussion is we'll learn about complex. Sir, please start problems. Okay, Shashidhar. Okay, I'll start problems. So just I'll complete this derivation and I'll start problems. Okay. So the I hope my voice is not breaking. My internet is proper, right? Because I'm using Wi-Fi. Is everything proper? Like, is my voice clear and video clear?
Yes, sir.
Okay. So like the aim of today's discussion is how to solve the circuit with the sine. So if the input is sine, then say I have a circuit, how to solve it easily. So we use something called complex numbers or phasors to solve that. But you will not appreciate it if I directly move into the complex numbers, because question is how do we know that that will work. So what I am trying to do is I'll teach the conventional way of solving the circuit, and I will show that how difficult or how complicated it is to solve using the conventional method and how easy it is to solve using the phasors. So you have to remember the phasor method only, not this. But one should also know this method, because say in a place where I don't want to apply phasors, or say you are teaching someone who doesn't know phasors, then they will have to follow this method. Even though it is complicated, one should know this method. And how will I remember this method? Because say I am teaching, if you ask me, how will I remember all these things? I am not by hearting it. I have solved it by myself before attending today's session. So I have taken some time and I have tried to solve. Maybe in between I make mistakes. Okay, then I'll check where I have made mistake. Then I'll say, okay, here I have made a mistake. Then I'll try to rectify. So that is how you should learn. You should try to solve it by yourself. Say you have attended this session, you have understood say 50% or 60% or say 40%. Then what you have to do is, after maybe I upload the video, again you take some time and then again you go through. But because now you know the process, now you try to do it by yourself and see whether you are able to do or not. Say you got stuck in between, then you go and check. Okay, I have made a mistake here. Okay, then maybe after few days again you try to do it, then you will understand better. So the more number of times you try to solve something, the better you will understand. Because this I have taught again, like last year I have taught, again I am teaching it this year. But I am like not coming to this sessions unprepared, again I'll solve, because again I have to be prepared, right? Because there is a lot of gap that has come since last year. I might or might not remember each and every step. So again I have solved. So then I know the complete picture. So whenever I am solving here, I'll be active and see each and every step. But if I don't come prepared and try to solve it here, then I'll make mistakes. Then it will not go anywhere. So practice is the important thing that you should be doing. So if you don't remember, like even when I was a student, what I used to, I'm still a student, not I was a student. So when I used to do these things, I used to practice a lot. Like I used to derive it multiple number of times, 3 times, 4 times, and then I'll get some confidence. So you have to invest a lot of time. You have to derive it yourself multiple number of times, not once or twice, at least 3, 4 times. So I used to derive as many number of times as possible to get the confidence, and with time you'll be understanding. Like maybe in the first time you'll not understand fully, second time you'll understand a little bit better, third time you'll understand more, fourth time you'll understand even further. Okay, so yeah, we'll go to the problems. Just 5 more minutes. I want to highlight one more thing. So this is the solution that we got. Shamita, is that clear?
Sir, how tan theta came?
So sin theta is this, right? Cos theta is this. Tan theta is sin theta by cos theta, right? So omega L by R.
Yes, sir.
Yeah, it is good that you are asking questions because you are trying to understand. I'm not sure about others. I hope others are also understanding. So one should ask questions. During my class, I never used to ask questions. I was a little bit shy, so I never asked questions. So I used to ask my friends, which is not a good practice. You should ask the person who is teaching so that they'll explain you. So now how will we find the A? We have to substitute IL of 0 equals to 0. So the initial condition is IL of 0 equals to 0. So once you substitute that, what you will be getting is A plus Vm by square root of R square plus omega square L square minus sine theta equals to 0. So now if I calculate it, I will get A equal to Vm by square root of R square plus omega square L square sine theta. Is this clear until this point? I have used this. I have just substituted t equals to 0 and I have calculated A. Now just let me quickly write an expression of IL of t. So the final version of IL of t is Vm by square root of R square plus omega square L square sine theta into e to the power minus RT by L plus Vm by square root of R square plus omega square L square sine omega t minus theta. So this is the overall expression. So now it has transient and steady state, which means this term is it will decay with time. So this is it will decay with time. So at t equals to infinity, this term will vanish. So when we say steady state, so whenever we say steady state, we'll consider t equal to infinite or when the values have settled. So at steady state, I can say my IL of t is equals to Vm by square root of R square plus omega square L square sine omega t minus theta. So is this clear until this point? So this is what I wanted to cover for today's theoretical discussion before we proceed further to the problems. So I have calculated IL of 0 to be equal to 0, which was given. So I have calculated A by substituting t equals to 0. Then I got A, and this is the overall expression after substituting A in this term. And at steady state, basically we are saying t is tending to infinite. So the first term will vanish and then only second term will be there. Clear, everyone?
Sir, Here Vm by root r square minus sin theta is there, no, sir.
Where? Which term?
How it became multiplied, sir?
Which term?
Above
Which
that
term?
step,
This one.
black color.
Actually, this is
Yes, sir.
Vm by square root of r square plus omega square into sine omega t minus theta. So it is, uh, sine of minus theta is minus sine theta, right? So if you put t equals to 0, it will be sine of minus theta, which means minus sine theta.
Um,
Got it?
that orange color equation, okay.
So I have
Okay.
substituted this a in this expression. So basically what I have done is I have this a expression I have substituted here. So then I have written the full expression. So that is my overall IL of t. It has one time decaying term and one term which is not dependent on the time. So then what happened? My IL of t has become only the second term because first term will vanish when t is infinite. This term becomes 0. So this is the steady state term.
Yes, sir.
Okay. So now, whatever we have discussed till now is how to solve an RC circuit with sine input in the conventional way using the differential equation. But in today's week, we'll be following one method using the complex numbers and phasors, which will makes which will make our lives very simple. So that problem I'm going to solve, but let us just quickly brush up our basics on complex numbers as well as the phasors. So the topic now is phasor. So I'll just give very basic intro about phasor. So what is a phasor? So in electrical circuits or in electrical engineering, whenever we are solving some circuits, we have J term, right, which is a complex number. So we write R into e to the power j theta as R angle theta. So R is like a magnitude and angle is like phasor. So R corresponds to the magnitude and theta corresponds to angle. So in the case of say my input is something like this. My input is Vm cos. So another thing. So R e j theta is what? R cos theta plus j R sin theta. And say Vm cos omega t plus theta is there. So usually we don't consider the omega t term because if the input has cos omega t, output also will have omega t term, but theta might change. So Vm cos omega t plus theta. So what we'll be considering this as? We'll consider this as Vm angle 0, or maybe let me just start from a basic example. So Vm cos theta is there. So we'll consider this as Vm angle 0 degrees. So cos theta corresponds to 0 degrees, right? So now let us say what is my Vm sin theta. So Vm sin theta. So cos of theta minus 90 is what? Cos of theta minus 90. Anyone? So what is cos minus 90 degrees? Sorry, this
What,
should
sir?
be cos theta. So say if my Vm angle theta is Vm cos theta. So what will make it Vm sin theta? So cos of theta dash should be sin theta. So what is theta dash? I can write theta minus 90, right?
90.
Yes, 90 minus theta or theta minus 90. Say I write theta minus 90 degrees or 90 minus theta. Both are same because cos of theta is cos of minus theta. So Vm cos theta is written as Vm angle theta. Vm sin theta will be Vm angle theta minus 90 degrees. So basically we are writing in terms of phasor form. 90 minus theta is also correct. So now any
So
input,
once
cos input or sine input, first we'll convert it into angle. Say we have cos omega t. So now let us get to the Good part. So now say we have Vm cos omega t. So whenever there is omega t, that will not consider into the phasor. We'll only consider the angle. So Vm cos omega t will be written as Vm angle 0. Okay, because we'll not consider the omega t. Whatever omega t plus theta, that only we'll consider. So Vm sin omega t will be written as Vm minus 90 degrees. So I should have written Vm cos omega t plus theta, Vm sin omega t plus theta. So this will be Vm cos omega t plus theta, and then this is Vm sin omega t plus theta. So like in the angle we'll remove omega t and then we'll write the rest of it. So if my input is cos omega t, we'll write Vm angle 0. If my input is sin omega t, we'll write Vm angle minus 90 degrees. So simple and straightforward, right? No confusion in the phasor. Any confusion or is this clear? Just a notation that we'll be following in the problems.
How theta minus 90 change?
So like cos of theta equal to minus, sorry, cos of minus theta, right? So sin theta equal to cos of 90 minus theta, which also can be written as cos of theta minus 90, right?
Yes.
Yeah, so that is the notation we have followed. Now let us come back to the elements. So these are all notations in phasor. So these are the notation that one should remember. So the resistor in time domain, in phasor domain will be resistor only. Inductance in the phasor domain we'll write it as j omega L, and capacitance we'll write as 1 by j omega C. So these are some notations in the phasor domain that we should remember. So just keep this in mind. You just have to remember that when we are writing in phasor form, R will be R, L will be j omega L, and C will be 1 by j omega C. Just you need to remember this. It's clear? Let us not get into the derivation of this because that is not covered in this course. Just you have to remember that L will be j omega L, C will be 1 by j omega C in the phasor. Like whenever we are solving the problem in phasor, it will be j omega L and this will be 1 by j omega C. Any queries until this point?
No.
Okay. So now let us solve one problem using the phasors that we have learned. So this will be our problem one. So instead of going into a numerical problem, let us do one thing. So let us solve this same problem using phasor. Okay. Let us solve this using phasor and then see whether we'll get. So basically why we are using phasors? Because to solve an AC circuit. So why phasors are needed? The basic reason is to solve AC circuits easily. Waiting for numerical problems, time is running. So Shashidhar, yeah, I'll do because if this concept was not clear, then you'll not be able to solve the problem. So this will, like this is also a numerical problem, but I'm like writing a generic problem. So just give me another 5 minutes. I'll move on to the problem solving session. So Vm sin omega t is what? So from this phasor, what is Vm sin omega t? Vm sin omega t, what is the phasor? Anyone? Vm angle 90 degrees. Yeah, very good. So let us convert this into phasor. Okay. So I'm redrawing it in phasor. So resistor will be R, omega will be j omega L. So this is my R, this is my j omega L, this is my Vm angle minus 90 degrees. So this is my I. So now we can solve it like a DC circuit. So my I phasor, what is I phasor? So phasor will have a bar on top. So can anyone tell me what is my I phasor? Voltage by impedance, right? Voltage is Vm angle minus 90 degrees by R plus j omega L, right? Clear? Or any queries?
So, sin omega t plus theta is
My
theta
sine of theta
minus
minus
90.
90. Yes, but since here theta is 0, right? Sine omega t only. So theta is 0. So it will become Vm minus 90 degrees.
No, sir. Previous you said sin theta is equal to cos theta minus 90, sir. But here we have sin omega t plus theta.
Your voice is breaking.
Only for sin,
So, sorry,
only for sin theta, that formula, na, sir. Cos 90 minus theta. For sin theta alone, na, sir.
yes, yes. So, so see, you have to compare under which case it is following. So, if it is Vm sin omega t, then Vm sin omega t, or say Vm sin omega t plus theta, then Vm angle theta minus 90 degrees, right? So, in this question, what is theta? Value of theta?
0.
0. So, once you substitute 0, you'll get Vm angle minus 90 degrees. So, this is my Vm angle minus 90 degrees.
Yes, sir.
Okay. So now let us solve for the denominator. So first let us solve the denominator. So the denominator will be R plus j omega L. I'll write it again in this form, square root of R square plus omega square L square into R by square root of R square plus omega square L square plus j into omega L by square root of R square plus omega square L square. Clear? So this I'll write it as cos theta. This I'll write it as sin theta. So now it has become R into cos theta plus J into R into sin theta, right? So basically, if I take R common, it will be cos theta plus J sin theta. So this can be written as R angle theta according to the definition. So my denominator can be written as the denominator, entire denominator can be written as R, which is square root of R square plus omega square L square angle theta, where my theta is, or say tan theta is sin theta by cos theta, which is omega L by R. So is this clear? Is this step? I have just uh, done it in different way. So omega L by R, Jnanadhar Singh, very good. So basically I have written it as cos theta and written this as sin theta, and then my tan theta is nothing but omega L by R. So I got this expression. So now let us substitute it in I phasor. So my I phasor will be Vm angle minus 90 degrees by square root of R square plus omega square L square angle theta. So one thing you have to keep in mind, say once we have I1 angle theta 1 by I2 angle theta 2, it is nothing but I1 by I2 angle theta 1 minus theta 2. So the same let us apply. So now once we apply, we'll get I phasor is Vm by square root of R square plus omega square L square into angle of minus of 90 degrees minus theta. So now if I convert this into time domain, I will get I of t is equals to Vm by square root of R square plus omega square L square into cos of omega t minus 90 degrees minus theta. So now I'll write it as cos of omega t minus theta minus 90 degrees. So I know cos of theta minus 90 is sine theta. So this is nothing but sine of omega t minus theta. So now let us write the final expression. I of t is nothing but Vm by square root of r square plus omega square L square into sine of omega t minus theta, where tan theta equal to omega L by r. So this is what we are getting. So I have just simplified the phasor to get the final expression. So if you see, whatever we have solved using the entire classical method and solved many equations, the same, like using these many equations, the same we have obtained using the phasor in like few steps, like lesser number of steps, getting the same. So Vm by square root of r square plus omega square sine omega t minus theta. Same Vm by r square plus omega square sine omega t minus theta, where tan theta is omega L by r. Here also tan theta is omega L by r. So using the phasor, you can solve the AC circuits easily by converting everything into phasor and solving like a basic DC circuits. So which is what we have done. So is this clear until this point? So this is just basic intro that I wanted to give to show how phasors are so effective in solving the AC circuits in a much simpler way. Sir, if we had taken initial phase 0 instead of minus 90, it would have been the same. Yes. So even if you take 0, it will still be the same. But I have told this convention that will be followed. So cos is considered as 0 and sine is considered as minus 90 degrees. But even if you consider sine to be 0, you have to be careful, because initially if you consider sine to be 0, then in the final also you have to consider sine to be 0 only. But initially if you consider cos to be 0, then at the final also you have to consider cos to be 0. So that will create confusion among you. So that's why I have told cos is 0, sine is minus 90. So that this is universal. It is followed in many books, also in many courses. So there will not be any confusion, and like you can be clear about it.
Sir, I didn't understand that steps.
Which step? This step. Which step did
Cos
you?
sin omega t plus theta.
This one. So this cos of omega t
Before
minus
that,
90 minus theta, you have understood?
before that, sir,
This one.
starting.
From this to this, or which one to when? Black to blue or blue to black?
Before that, sir, you wrote general formulas.
This one.
No, sir, you wrote sin theta is equal to cos 90 minus theta.
This one.
Ah, yes, sir.
What did you not understand?
Your Vm cos omega t plus theta, how it become Vm theta?
So whenever we write in phasor, so Vm will write Vm, and angle is what is the angle in addition to omega t. Say here, first of all, you have to remember we have Vm cos omega t plus theta. So this is the convention that is followed. So Vm will be written in Vm. Say if it is theta, then we'll write theta directly. But it has omega t plus theta, right? Like what I mean to say is, if it has omega t plus theta, in phasor we'll not write omega t, because in phasor there is no time domain expression. So we'll remove this time domain expression and we'll directly write theta. Whereas if it is sine omega t plus theta, then I can write sine of omega t plus theta as cos of omega t plus theta minus 90 degrees. So I'm basically writing theta minus 90 degrees. Sir, taking what as reference? So cos is always our reference. So basically, uh, say we have R angle, or say, so basically I have something like this. Say I have V1 angle theta 1. So this in time domain it will become V1 cos omega t plus theta 1. So now if I have V2 angle theta 2 minus 90 degrees, now it will become V2 cos omega t plus theta 2 minus 90 degrees. So this can be written as omega 2 sine omega t plus theta 2, because theta minus 90 is nothing but cos omega, theta minus 90 is nothing but sine theta. Sir, I am saying omega t as reference. Yes, omega t is as taken as reference. So that's why omega t we don't consider in phasor, because we consider with respect to omega t. Okay, adding to my point. Okay, got it. So now is this clear, Shamita?
Then how you wrote VM 0 degree, VM minus 90 degree?
So here what is theta? In this question, what is theta? If you compare
Theta
these two expression,
0.
0, right? So that's what I have substituted. Basically, I have substituted theta as 0.
Yes.
Okay. So now let us quickly go through problem solving session, and let us solve few problems. See, basically why I have spent so much time, because in the problem, like you have to, uh, while solving the problem, you will see that it is very much important to understand the concept, because if you do not understand the concept, you will not be able to solve any of the problem. So the concept is very much needed. That's why I have spent some time on the problems. So this will be our problem 2. Basically, we have to find IL angle theta, IC angle theta, IR angle theta. Okay. So this will be our problem 2. So first we have to convert this equation into phasor. So using this, you have to do first R will be R, all these things, and omega they have given 400. Omega equal to 400. Okay. Now let us transform this circuit. So can you tell me the values of R and L and C in phasor form? Just calculate, and can you tell me quickly? So this they have given as plus minus 200 angle 45 degrees volt, and this they have given 70 ohm. This they have given 30 ohm. R remains R, but L is j omega L and C is 1 by j omega C. So can you quickly calculate and tell what is the value of L and what is the value of C? So someone has mentioned in the chat I equal to L equal to J10. Okay. And C, Shashidhar, you're also following, right? L is J10, C is minus J10, R equal to 70/30. Gyanendra, very good. And Shashidhar, are you following? So this will be J10 and this will be minus J10. So very good. Yes, sir. Okay. So now what will be the parallel combination of these two? J10 and minus J10, if they are in parallel, what is the effective impedance? Effective impedance is infinite, Shashidhar, not zero, because uh, it will be 10J into minus 10J by 10J minus 10J. So it is basically infinite. So as if there it is open. If it is short circuited, yes, denominator becomes zero. So as if once these two are there, then the resistance is infinite. So both of them together can be considered as open circuit. So now let us redraw the circuit. Once we redraw the circuit, we will have basically resistor here, phasor here, and this is 200 angle 45 degrees. Shamita, are you following?
Sir, I'm getting 1 by J point 1 for C. Sir.
C, C. Okay, okay. Let me. So L, you got it right.
Yes, sir.
So 1 by j omega c. Omega is how much?
400.
C is how much?
0.25 into 10 to the power of minus.
Okay, so j into 4 into 0.25 into 100 into 10 to the power minus 3, right? 400 is 4 into 100, 0.25 milli is 0.25 into 10 to the power minus 3, right? Agree?
Yes, sir.
So 4 into 0.25 is how much? 1, right?
Yes, sir.
100 into 10 to the power minus 3 is how much?
10 minus 1.
10 to the power minus 1. So 1 by 10 to the power minus 1 is how much?
10 by
10.
j.
So 10 by j. 10 by j is nothing but minus 10j.
Yes, sir. Okay.
Okay. So yeah, so now these are infinite. This you understood, right? How they are infinite.
How, sir?
Minus 10j and 10j if they are in parallel. So it is 10j into minus 10j by 10j minus 10j. So it is infinite as if there is infinite resistance. So if I combine these two, the resistance is infinite. Combining these two. So they are kind of open circuit. So this is the final equivalent circuit, right?
How we are finding, how 10j minus 10j came, sir?
So what is the effective impedance of these two when they are in parallel? Can you tell me the value?
We cannot add L and C now, sir.
Meaning like it is an impedance, right? You can find the effective impedance, right? Like if two
I
impedances
don't.
are in parallel, the effective impedance will be Z1 into Z2 by Z1 plus Z2, right?
Okay, sir.
So like resistance. So two resistances are in parallel. So the effective resistance will be R1 into R2 by R1 plus R2. Similarly, if two impedances are in parallel, the effective impedance will be Z1 into Z2 by Z1 plus Z2. So which is what I have done. And the impedance is coming infinite. So when I combine those two impedances, the overall net impedance is infinite as if there is open circuit. So I can neglect those two because the resistance is infinite combined, not individually. So as if both of them are when combined it is having infinite impedance, so current will not flow, so I have removed them.
Yes, sir. Okay, sir.
Okay, so now everyone please calculate the value of v and tell me what is v here. V is nothing but 30 by 30 plus 70 into 200 angle 45 degrees, which is how much? 60 angle 45 degrees, right? Getting everyone?
Yes, sir.
Okay, so now this voltage is this voltage, so the current through the resistor is voltage by resistance. Current through the inductance is voltage by inductance. Current through the capacitance is voltage by capacitance. Yes, sir. 2 angle 45, V is 60 angle 45. Very good. So now IR angle theta R is how much? This voltage by resistance, right? So what is IR angle theta R? IR angle theta R is nothing but voltage by 30. So how much is this? 2 angle 45 degrees, right? Everyone agree? Okay. So now what is IL theta L? IL theta
Unit is
L is
ohm,
what?
no.
Voltage by 10J. Sorry, any query? First of all, there is less than a minute. So if this meeting end, kindly join back. That will be our last 40 minutes where we'll be extensively solving problems. So kindly join back. Anyone has any query until this point?
Unit is ampere, no, sir. IR.
Oh, sorry, sorry. Yeah, yeah. Very good. Thanks for correcting. Yeah. Yes, ampere. So 10 angle J is nothing but 10 angle 90 degrees. Or how much? 10 angle 90 degrees, right? So 60 angle 45 degrees by 10 angle 90 degrees. So you can check R angle theta equal to R into cos theta plus J sin theta. So now you substitute R angle theta as 10 angle 90. You will get 10J. Clear? How I have written the denominator?
You made it as 10 angle 19 answer.
Yes, yes, yes.
Instead, we can write minus 6 angle 45 answer.
My no, the denominator part you are asking, or which one are you asking about?
For whole, sir, after 10
That
J
yes, yes,
will
yes. No, no, I meant to simplify because the meeting got ended. I have not simplified. So this I can write as 6 angle minus 45. Yeah, you are very right.
no, sir. Instead of writing 10 angle 90,
Huh.
we can cancel that 60 and 10, and for J, it goes if it goes to numerator minus 6.
Minus 6. Okay. Very good question. So whenever we write in R angle theta form now, so very, very good. Thanks for pointing this out. So whenever we write now, here R is a constant. Okay. This is constant and it is positive always. Okay. It cannot be an imaginary number. So R cannot be 3J. R cannot also be minus 3. R can only be 3. So whatever is J, J basically contributes to 90 degrees. So if you see J, you can write it as one angle 90 degrees. So that J has to be reflected in the angle. Say R angle theta is R cos theta plus J sin theta, right? So now substitute R as 1 and theta is 90 degrees. So you will get 1 angle 90 degrees is equals to J. So if you see J, I am not writing it as J angle 0. That is wrong because R is always constant, real constant, and it is positive. So J, I cannot write it as J angle 0 because R has to be a real number and it has to be positive. So I have to write it as 1 angle 90 degrees. Yeah, this is very good question because many people may make mistake here. So R should be always constant and J should be reflected in angle. So now is that clear?
Yes, sir.
Others also, is it clear? So now what is IC angle theta C? It is V by minus 10J. Yes. So now minus 10J will become, so now I cannot write like minus 10J as minus 10 angle 90 degrees. That is wrong because it cannot be negative. So V will be 60 angle 45 degrees. Minus 10J will be what? 10 angle minus 90 degrees. So now this will become what? 10 angle 2 or how much? So 6 angle 135 degrees, right? 6 angle 135. So everyone got this? So these are the results that we have obtained. So if you see, the problem is pretty simple and straightforward. Although there are 8 sub questions in this, what we have done is we have just first converted into everything in phasor form. Then we have simplified it. Then we have calculated this voltage. Why we have calculated this voltage? Once we calculate this voltage, currents is nothing but voltage by impedance. So I got voltage first and then I have calculated all the currents. So now let us go and check whether what we got is correct or wrong. IC is what? Anyone? How much is IC? 5 angle or 6 angle 135 degrees, right? So 6, it is in between 6 and angle they have strictly mentioned it should be 180 minus 180 to 180. So it is 135 within that range. So fine. IL is 6 angle. So it is in this range 6 angle 45 degrees or minus 45. So 6 angle minus 45. So minus 45 is same as what? 360 minus 45, right? Meaning 315. So minus 45 and 315 both are same. But here they have specified the angle should be minus 180 to 180. So it is minus 45. IR is 2 angle what? 2 angle 45. So 2 is in the range and 45 is also in the range. So is this clear until question 6? Is it clear? Everyone? Yes. Shamita and Shashidhar, Kumar, Vishnu, everyone, is it clear? And Sasi, Bhushan? Yes, clear. Okay. So
Yes,
now this is one problem of solving currents. Now in this sub-problem only, there is another important concept called power. So first, let me just give the formula for power before we solve the problems on power. Yes, Shashidhar, yes. So there is something called complex power, which is very important concept. So complex power. So complex power is nothing but it is represented by S, which is nothing but V phasor into I phasor conjugate. So now it has a real part as well as an imaginary part. So this is P plus J into Q. So because it's a complex number, I'll write it as P plus JQ. And the notations are to be followed must. S means complex power, P means active power, Q means reactive power. So let us define it. This is sorry, very sorry. So this is S is complex power. P is active power and Q is reactive power. Okay. So complex power unit is volt ampere. Active power unit is watt. Voltage reactive power unit is volt ampere reactive. So VA is volt ampere. Watt is what you know, and VAR is volt ampere reactive. So the units are also very important. So if someone says the power is 2 VAR, it means they have given reactive power. Many times in the questions they do not specify what is whether it is active power or reactive power, but from the units we can understand what it is. So this is some simple concept that everyone should be aware of. So is this clear?
yes, sir.
Okay. So problem two. So problem three will be based on the complex power. Okay. So this will be problem three. So in the problem three, what they have asked in the question is what is the active power supplied by the source? What is the reactive power supplied by the source? So let us first calculate the complex power. So for complex power, I need V phasor as well as I phasor, right? So V phasor is already given, right? So let us take this circuit down. So V phasor is already given. So now what I have to find is I phasor, right? So what is this I phasor? Anyone? What is this I phasor? Can anyone calculate and tell me what is this I phasor? Anyone? So someone is mentioned 2 angle 45, 2 angle 45. Yeah, very good. Yeah, Shamita got it right. 2 angle 45. So now can you substitute this V phasor, I phasor and calculate S? What is complex power? So whoever has calculated, just calculate S. S is nothing but V phasor into I phasor star. So star is nothing but complex conjugate. R angle theta, what is complex conjugate? R angle minus theta. So V phasor is 200 angle 45 degrees. And I phasor is what? Anyone? What is I phasor star? Minus 45, right? So 2 angle minus 45. Yes. 2 angle minus 45 degrees. So please keep these two formulas in mind. Let me just write it here. So one is say I have V1 by V1 angle theta 1 by V2 angle theta 2 is there. Then I can write simply V1 by V2 angle theta 1 minus theta 2. Similarly, if I have V1 angle theta 1 into V2 angle theta 2, I can write, so I can basically multiply V1 V2 and then add the angles. So just like logarithmic, if they are divided, then angles will be subtracted. If they are multiplied, angles will be added. So now can you tell me what is the value of this? Anyone?
Sir, how
400
minus
plus an
45
angle
degrees?
is 0.
So I phasor is 2 angle 45 degrees. So I phasor star will be negative of that angle, 2 angle minus 45 degrees. Because it's a complex conjugate, angle will be negative.
Okay, sir.
Okay, yeah, Vishnu said 4 angle 0 and Jnanendra Singh said P equal to 400, Q equal to 0. Very good. So now if you multiply these two, what we will be getting is we will get 400 angle 0 degrees. So now let us expand this. So I can get 400 plus J into 0. So my active power, which is P, equal to 400 watt, 400 watt, and Q is 0 volt ampere reactive. So everyone got this, how to solve power problems. So
Yes, sir.
my active power is 400 and my reactive power is 0, directly 0. Everyone got it? Any queries until this point
Yes,
before
sir.
we proceed further? Okay, let us solve one more problem. Yes, sir. Okay. So let us go to new page. So we have solved problem 3. Now this will be problem 4. So problem 4 has based on superposition. So we have to solve based on superposition. Okay. So this will be our problem 4. So this will be little bit lengthy compared to previous problem, but also a very good problem. So this will be our problem 4. So superposition means what we will do, we will consider one source at a time. Sir, solve first problem. Which problem? Shashidhar, can you? First problem is what we have solved, right? This is the first problem we have solved. So this is the second problem, right? In this assignment, RMS values. Not getting which problem? In this year assignment you are talking about, or which one? This year assignment, RMS values of current. Where like in this assignment or this year assignment, 2025 assignment? Uh, can you, because in the assignment that I have, I don't see any RMS values. Last year only. So this is last year assignment. So this is 2024 assignment. So which question are you talking about? RMS. This IC. So we have solved, right? IC is what? IC angle 45. IC is 6 angle 135. We have solved, right? I have also shown that they are matching 6 angle 135 degrees. We have solved, right? Can I share screen? No. Uh, okay. This one, right? RMS value. This one you are talking about, or which one? Or can you attach the screenshot and write in the open in the like copy paste in the chat so that I can open and everyone can see. This one only. Okay, but this is solved, right? This problem is solved already. We have solved this problem, right? You have also solved. Shashidhar, we have solved this problem, right? I will share my screen. Okay, please share. Shashidhar, please make it quick because we are running out of time. We have 20 minutes only left. We have to solve another problem. So yeah, please make it quick. Share the file in the meeting. Okay. Okay. So you have shared the problem. Okay. This model. Okay. Acha, you mean to say this question? This, so this is last question, no? Not first question. Yes. Okay. So, uh, everyone, is it fine if I solve this question instead of this question? Because we'll get only time to solve one question. So either I can solve this or I can solve this. Will it be okay if I solve this question for everyone? We can use nodal analysis for this, right? Yes. Yes, Vishnu. So we have to write nodal analysis. So this will be okay. Let us see if I think I can solve this question very quickly because this is very simple problem. Then we might come back to this problem later. So let us do one thing. Okay. So this will be our problem 4 for today. So we can solve this easily. So then we can go to that problem if time permits. So this will be our problem 4 for today. So what I'm going to do is I'll apply nodal analysis as someone has already mentioned. So I'll call this V phasor. Okay. And I know this voltage is what? 200 angle 0 degrees. This voltage is 200 angle minus 120 degrees. This voltage is 200 angle 120 degrees. Okay. So now what is my I1 angle theta 1? Anyone? I1 angle theta 1 is 200 angle 0 degrees minus V phasor by 100, and I2 angle theta 2 is, someone has mentioned 2. No, no, it is not 2 because it is 200 angle 0 minus V. V phasor is there by 100, and then 200 angle minus 120 degrees minus V phasor by minus J 100, and then the third one is I3 angle theta 3 is 200 angle 120 degrees minus V phasor by J 100. Clear how I got these three expressions? Basically, I have considered it to be V phasor V bar, and then I have calculated the currents individually. Clear until this point, everyone? Yes, sir.
Yes, sir.
Okay. So now let us apply KCL at that node. So summation of the currents entering the node will be 0. So I1 angle theta 1 plus I2 angle theta 2 plus I3 angle theta 3 will be 0. So once you substitute I1, I2, I3, everything in this equation, so then I'll just skip one step and then I'll write it. So I'll get 200 angle 0 degrees by 100. So constants I'll be writing on the LHS and rest I'll be writing on the RHS. Minus 120 degrees by minus J 100 plus 200 angle 120 degrees by J 100 is equal to V bar into 1 by 100 plus 1 by minus J 100 plus 1 by J 100. So is this clear? I have just substituted the values, and V bar I have taken onto the RHS side and I have taken common, and rest of the constants I have kept on the LHS side.
Yes, sir.
Okay. So now let me just skip the mathematical part. So if you calculate, you will get V phasor to be something like this: 546.4 angle 0 degrees. So this is just a calculation which you can do in the calculators. So uh, you have understood the process, right? Like forget about the last step, how to do calculate it mathematically, but you have understood, right? How to get V phasor. Once you get V phasor, what you have to do is you have to substitute the V phasor in these equations individually. You have to calculate I1 angle theta 1, I2 angle theta 2, I3 angle theta 3. Okay, sir, RMS how to take? So whenever they have mentioned all quantities in this question represent RMS values. So this is RMS value, this is RMS value, this is also RMS value. So now once you got V phasor, you have to calculate I1 angle theta 1, I2 angle theta 2, I3 angle theta 3 by substituting V phasor in this. So once you do that, I'll just write down the values that you will be getting. So I1 angle theta 1, you will be getting 3.464 angle 180 degrees. So this R, it itself is RMS value. I2 angle theta 2 is 6.692 angle minus 75 degrees, and then I3 angle theta 3. So I have basically substituted this V phasor in that, and then I got this 6.692 angle 75 degrees. So now the
Sir,
RMS value, yes,
you have solved by using calculators, sir.
yes, I have solved using scientific calculator.
But there, in exam, it is not allowed, no, sir.
I'm actually that part I'm not sure. Like people used to ask me, so I used to ask them to contact the course instructor itself, like because it is, uh, like I'm not aware like what calculator is provided. So you better ask the course instructor. Like you just drop a mail to him, you can get the email ID and just ask what calculator will be provided, so you can check whether you can solve it using that or not.
No, sir. It can only simple operations. We can't do like this using it complex.
Okay, then what you have to do is you have to expand it. So you have to like what you will be doing is 200 angle 0 by 100 is 2 angle 0, and then the base one will be 100 angle minus 90 degrees. So this will become 2 angle minus 30 degrees, and then this will become 100 angle 90, so it will become 2 angle 30. So now again 2 angle 30 you have to expand 2 cos 30 plus 2j sin 30, and then this will be 2 cos 30 minus j 2 sin 30. Then you have to apply and then expand. So you have to convert it into a plus jb form, and then you have to do, because in usually in our college at like BTech level, scientific calculators are allowed. So that's why we teach them how to solve this using scientific calculator. So in the scientific calculator, you can write this in the numerator, write this in the denominator, and once you write the expression, you will directly get V bar right away. So that's why when I have solved, I have used the calculator and right away I got the V bar. I did not simplify this part, nor I have simplified this part. Anyway, this part is 1 by 100. So I have directly written that, but you have to individually solve, expand, and then combine LHS. Similarly, RHS you have to combine, and then again you have to do. It is little bit lengthy, but if the scientific calculator is not provided, then I request everyone to solve, because then only you will not make any mistake in the exam, and you will also be habituated with the calculations. Okay, so this value itself is RMS value. Similarly, this value is the RMS value. This value is the RMS values, because in the question they have mentioned these voltages are all RMS values. Now let us go and check whether whatever we have got is correct or wrong. So I1 is how much? I1 is 3.464, which is in this range, and angle is my 180 degrees. So 180 degrees, and I2 is 6.692 minus 75. So I2 is 6.672 minus 75 degrees, and this is 6.672 plus 75 degrees. So you do these calculations, but these are just simple. So it is some mathematical calculating thing. So that's why I have skipped that part. So you can cross check the answers whenever you get free time. So someone has mentioned, sir, next problem. Okay. So let us quickly go to this problem. So in this problem, we have voltage source as well as current source. Superposition means you have to apply superposition. So we'll consider either voltage or we'll consider current. So as I have mentioned, sine theta, sine omega t will be what? 20 angle minus 90 degrees, right? So let us go back. So Vm sine omega t is Vm minus 90 degrees. So which is what I am following now. So this is 20 angle minus 90 degrees. This is also 5 angle minus 90 degrees. So first I'll consider voltage source. So when I consider voltage source, what happens to the current source? Anyone? Current source open circuit. Yes. Shamita, you're also following, right? I'm little bit going faster because we are running out of time, but I'll try to explain the concept. Maybe I'll skip the mathematical part. So in this omega is 500, right? In this case, 500 radians per second. So now uh, it will be open circuit. So it will be something like this. So the circuit will be inductance, capacitance, and then resistance, and this is open, and this is the voltage source, and it is 20 angle minus 90 degrees. So if you calculate, it will come J14, and if you calculate this, you will get minus J 0.2, and then let this be plus minus VC1. Note there will not be any current flowing in this part because it is open circuit. So now what is VC1, everybody? So minus J 0.2 by J 14 minus zero point 0.2, 13.8 into 20 angle minus 90 degrees. Agree everyone? Everybody agree? Yes. Okay. So now, uh, Shamita, you're also following, right?
Yes, sir.
Okay. So now if you calculate this, you will get VC1 equal to 0.289 if you calculate angle plus 90 degrees, because there is one minus sign over here. Minus sign corresponds to another minus 90 degrees. So minus 90 minus 90, sorry, minus 90 minus 180 or plus 180. So it will be 180 minus 90. So 90 degrees. So minus corresponds to plus or minus 180. So minus 1 is nothing but 1 angle 180 degrees, because I cannot write minus 1 angle 0, as I have told, it cannot be negative. So using this, we'll get 180 degrees. So now let us convert this into time domain. So my VC1 of t, VC1 of t will be what? 0.289 cos omega t plus 90 degrees, right? So now my VC1 of t will be 0.289 plus omega cos 90 plus theta is what? Minus sin theta, right? Sin omega is what? 500. So 500 t. Agree everyone? I have converted the phasor into time domain expression. Everyone agree?
Sir, how it became open circuitry that sense?
Because it is current source now, so we are applying superposition, so current source will be open when I consider voltage source. Similarly, when I consider voltage, so current source, voltage source will be short circuit.
Then we should derive one more time. We should solve one more time by short circuiting the source and
Yes, 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 yes,
this.
yes, yes, you're right, we have to solve. Until this point clear everyone? So now let us go to current source. So if you see, whenever we are considering different sources, omega is different, right? So for current source, omega is different. For voltage source, current omega is different, because the omega of this is 600 radians per second. Omega is 600 radians per second. So again, L will change, C will change, because they are dependent on omega, and this will be short circuit. So if you do that and calculate L, you will be getting something like this. C, and then you have a resistor, and then you have a voltage source. Okay. So, sorry, current source, and they're representing it like this. So let us also represent using like that. So let me write the values. So if for this omega, if you calculate again, you will get 20 angle minus 90 degrees. Sorry, I'm very sorry. So this you will get J 16.8 and then this you will get minus J by 6. And we are asked to find this voltage plus minus VC2. So this is my VC2 phasor which I am trying to find, and the resistance is 75 and the current is 5 angle minus 90 degrees ampere. So what I will be doing is I will be, because I know the current in this, if I calculate the this net impedance, then my voltage VC2 will be net impedance into that current, right? So what is my net impedance? My net impedance, uh, my net impedance Z will be J into, sorry, J 16.8 into minus J by 6 by J 16.8 minus J by 6. Agree, everyone?
Yes.
Yes. So now, if you calculate,
Hello.
you will be getting 0.168 angle minus 90 degrees. So now what will be my VC2? This Z into the current, right? So my VC2 phasor is nothing but this Z, which is 0.168 angle minus 90 degrees into the current, which is 5 angle minus 90 degrees. So what it will become? Minus 180 degrees, and 0.168 into 5 is 0.841 angle minus 180 degrees. Minus 180 degrees is nothing but plus 180 degrees. Both are same because theta and 360 plus theta both are same. So I am writing in 180 degrees. So now if I write
Sir,
the, yes,
uh, sir, why we should combine both these two?
which two?
Uh, this inductor and capacitor.
Uh-huh.
Why we should take it as a parallel combination? Only VCT is across only capacitor only.
Yes, but I have to find the current through the capacitor, na, then in that case to
So can
calculate
we
this
apply
voltage.
current division rule? Can we apply current division rule for that?
Yes, so you can apply current division rule and then multiply with the capacitance. That is also fine.
That is also right. Sir?
Yes, yes, that is
Okay.
also fine.
Yeah,
But
okay.
this
Thank
is
you. Thank you.
like my comfortable way. Usually, I reduce the impedance and then multiply by current. But you can do the other way around. You can calculate the current through this and find the voltage, or you can find the current through the inductor and find this voltage as well. Because either case, it is the same.
Yes, sir. Thank you.
Okay.
Thank you. Sir.
Yes. So now VC2 of t will be 0.841 into cos of omega t plus 180 degrees, right? So then it will become what? Minus 0.841 into sine omega t, right? Because it is cos omega t plus, sorry, cos omega t plus 180 is minus cos omega t. So we'll get something like this. But if you check in the question, they have written both in terms of sine. So I have to convert this cos also into sine. So what I will be writing? I will be writing my VC2 of t will be minus 0.841 into sine omega t plus 90 degrees. Then you might ask me, sir, why did you keep the minus outside? Instead, you can take that minus inside and then you can add 180 degrees more. So what is wrong? So because they have mentioned my phi should be minus pi by 2 to pi by 2, I have taken this minus outside so that the angle will be within the range. So I got two terms. One is corresponding because of the voltage source. One is because of the current source. So in the voltage source, which is sine 500 t plus pi, it is minus 0.289 sine 500 t. So A is what? Minus 0.289 and theta is 0. So let us quickly go and check. A is minus 0.289, which is in this range, and theta is 0. Similarly, my B is minus 0.841 and this is 90 degrees, and if you check they are asking in terms of radians, so this will be pi by 2, which is 3.14 by 2, which is 1.57, minus 0.841 minus 0.841, and this is 1.557, right? 1.57 because it is 3.14 by 2. Yes, sir. Okay, good session. Yeah, thank you, Shashidhar. So Any queries in this final problem? So we are approaching towards the end of our session. So any queries in this problem? Although I have gone a little bit fast for the two problems, but I hope that you have gotten the idea how to solve the problems. I have just skipped the mathematical calculation part to save time, but I hope I have made myself clear with the concept.
Sir, to find VC1,
Yes,
I current source should be short circuited. As we
current will be
have
open
done
circuit.
open
So
circuited.
current will be open and voltage will be short. So you have to keep this in mind. Whenever we say current will be open circuited always and voltage will be short circuited. So if you want to get the final one, applying superposition, it will be VC1 of t plus VC2 of t. So always in DC circuit also, if you remember in the earlier session, we have done the same. Current source will be always open, voltage source will be always short circuited. Clear?
Yes, sir.
Okay. So if you don't have any queries, I'll just quickly summarize what we have gone through today. Thank you. Yeah, thank you, Shashidhar, and thank you, Sashi Bhushan. So today we have started with the mesh and nodal analysis with time varying source. First, we have gone through the classical approach of solving the differential equation, and we have seen the calculations are lengthy, complicated, and it takes a lot of time, also a lot of calculations in order to get the steady state time domain expression. But when we are not considering the transient like response, if we are only concerned about the steady state expression, then instead of going through the classical approach of solving the equation by the differential equation, we can also use phasors to solve the AC circuits easily. Only the steady state, okay? Not the transient part, only the steady state. So for that, we have gone through the conventional conventions of the phasor. So you follow these conventions, and we have seen that RLC should be converted into phasor form first, and then we have to start solving the circuit. So the same circuit which we have solved using the classical method, using the differential equation method, we have converted that into the phasors, and then we have solved, and we got the same expression. And keep this in mind, this is only the steady state expression. Using this phasor, you will not get the transient part, because this week is all about steady state. So that's why we are only bothered about the steady state terms, and which you can use, uh, which phasors can be used to get it. So then we have applied the phasors and solved a couple of problems. So we have
Steady
converted
state
the circuit.
means
Sorry, sorry.
steady state means,
At t equal to infinite. Steady state means at t equal to infinite.
but they asked using AC sources, na sir.
AC source, it is steady state, na? Like at steady state, what is the phasor? It will be in sine, right? So my output is also in terms of sine, but there will be one decaying term, exponentially decaying term, which we are not bothered about. We are only bothered about the sine term and cosine term. Clear?
So steady state means it's not DC state,
No,
sir.
not DC, not DC. Sine, sine. Steady state means not only DC always. There is less than a minute if this meeting can kindly join back. Okay, then we have solved a couple of problems. Then we have also discussed about complex power, and then we have also solved one interesting problem using nodal analysis, and then we have solved another problem using superposition. So that is all about today's session. I wish this session was helpful, and I wish you all the best for your assignment 3. So with that, we can end this session. Good night to everyone, and I wish you all the best.
Sir, by solving this problem solving session problem
Yes.
and assignment problems, can we pass the exams?
Yes, yes,
Or
definitely,
should we
definitely.
practice more time, sir?
No, see, by solving this, you will get the concept. But solving more problems will give you more confidence, and it will make you like comfortable with the calculations. Whatever I have discussed in today's session, plus the problems that we have solved, would be sufficient to do well in the assignment. But when it comes to practice, that is a different thing. I'm saying this is sufficient to pass the assignment, but you should also solve more problems so that you will be more comfortable with the calculation. See, if I in today's session I have not done any calculations, nor you have done the calculations, but you should do those calculations by yourself, and you will make mistakes which you have to rectify while practicing so that you will not make them while solving the assignment. So I suggest you to solve problems. Maybe in the other problem solving session, you just open and see what problem they have solved and try to solve it by yourself and see whether the answer is matching or not. And always, if any course that is related to math, you should solve as many problems as possible, and that is universal. You cannot neglect that. Whether it will be probability, whether it will be calculus, whether it will be trigonometry, or geometry, or any other mathematical topic, you should always solve as many problems as possible so that you will understand the concept better. So in math you will understand the concept by applying it in the problems, then you will correlate the concept with the problems. Also, as calculation is a part of math, you should solve as many problems as possible so you will be more comfortable with the calculations and not make more mistakes in the assignment.
Sir, you, where can I get questions to solve more problems?
Okay, so in last year I have solved assignment 2023. So that's why I have taken a different assignment this year. So let me give you the link of the my previous year lectures. So I'll just mention few links in the chat box, which you keep it always with you. Okay. So last year also I have conducted the session where I have uploaded I have discussed these concepts and I have uploaded the videos in the YouTube. So I have given the link to my last year problem solving session where I have solved 2023 year problems. Although the problems are little bit similar, the values are different. So you can go through those uh, lectures and then you can pause the video and try to solve it by yourself before seeing the solution, which I have also given in that video. And then I am also giving the drive to access the last year notes. So you can also access the last year notes where I have solved all the problems and explained the concept. So I am repeating it again, so you need not go through that. But if you want to solve the problems, you can always go through my last year sessions where I have solved different set of problems, and then you can practice those problems. Are you able to access it?
Sir, I'm going to college, sir, so I don't have much time to practice also. I'm asking, how much problem should I solve to get confident and to get pass in exams?
Okay, okay. So, like it is again subject to, it is different from person to person. It is not that you have to solve to gain confidence. Sometimes by solving one or two problems, we'll get confidence. But calculation, that will only come by solving as many number of problems as possible. So what you can do is, how much time you have, you try to spend it effectively by solving few problems. Say whatever we have discussed today, try to solve it again by yourself without looking at the solution after I upload the video to the YouTube, and see if you are confident enough or not. If you are not confident enough, then go through my previous year problem solving session and try to solve them and see whether you are confident enough or not. But again, it is subjective. Sometimes I don't feel confident by solving two problems. Maybe sometimes I feel confident depending upon uh, like how I solve the problem. Say I have solved two problems, I was able to solve both the problems, then I'll feel more confident. Say if I am not able to solve both the problems, then I have to solve some more problems to gain that confidence. So it is not always fixed, it is subjective and it depends on many factors. Say if I'm able to solve, then that will give me confidence, but if I'm not able to solve, then I have to solve few more problems to gain that confidence. So it is not straightforward, but you start solving the problems, you will know when you are confident enough. But until that time you have to solve problems. I know it is difficult if you go to college, but try to put some extra time so that you will gain confidence. And keep one thing in mind, all these weeks are interconnected. So if you are not confident of one week, then you will not be confident in the upcoming week. So consider each and every week with utmost seriousness and try to solve as many problems as possible in the time that you have.
Sir, is this question similar to gate questions, assignment questions?
That I am not sure because I have not appeared for gate, so I am not aware of what type of problems will be asked in the gate. So I am not the right person to discuss regarding gate.
Okay, sir. Thank you, sir.
Okay, thank you. And yeah, it was a nice session. Great interacting with you people. And yeah, all the best for your assignment 4 and see you in the next week again on Monday. Thank you and good night.
Thank you, sir.
Thank you.